check. Hello, those of you at home. Here's your warm-up. You're helping your cousin Amelie with her math again. She's still struggling with addition. Remember, with all that stuff, you can read. Read this and tell me what you got. Pause the video, think about it, and here we go. Okay, everybody. Can I get you in 5, 4, 3, 2, 1. Evan, what's Amelie doing incorrectly this time? Perfect. Yeah. It's not about lining things up to the right or the left. It's about lining up the decimal to make sure that the place values line up. We need to make sure the ones line up with the ones, the tenths line up with the tenths, the hundredths line up with the hundredths, and so on. So let's see what we can do with this, guys. It is the 58th day of school. You know, 58 shots is the lowest golf score ever achieved in a Tier 1 tournament. That was done 4 times. Ryo Ishikawa and Kim Seong-hyung in the Japanese golf tournament, Jim Furyk in the PGA Tour, and Bryson DeChambeau in the LIV. Any golfers out there? Any golfers out there? So I tell you, it's 58 shots on a par 70 good? That's unbelievable. It's only happened 4 times. Only happened 4 times in the history of Tier 1 golf tournaments. Yeah.
I'm confused. So like 58 shots to get it in the hole?
No. It's 58 shots for the whole course. 18 holes. Yeah. 18 holes, 58 shots. It's happened 4 times. Yeah, exactly. Come on. I think these were, I'm not sure if these were on 72s, but they might be, because I don't know if the Japanese one is slower, but anyway. Can I get you in 5, 4, 3, 2, 1. Happy Veterans Day, everybody. Yay. Yeah, it's Veterans Day today. I want to go real quick to get this going, guys. Does anybody, by raise a hand, have veterans in their family that they wish to tell me about? I would love to hear about it. Yes, Juliet.
My great-grandpa was in the Marines.
That's awesome. In the Marines, probably World War II is my guess. Great-great-grandpa. That's awesome. Oh, you're just your great-grandpa. Yeah, so probably World War II, maybe Korean War. That's amazing. Very good. Jack.
My great-grandpa was in World War II, I think.
Mm-hmm.
Just great-grandpa. I don't know.
Sure.
Yeah.
I know when you get that far out, it's hard to do. Yeah, Tate.
My great-grandpa served.
That's awesome. You love to hear it. Yeah, Garrett.
My great-grandpa was MIA in World War II, but they found him in France.
They found him in France. All right, I love that. Absolutely. Fighting the good fight in France. Yes, Dean.
My grandpa was a spy in one of World War II.
Ooh, that's cool. That's sneaky. I love it. Very cool. Samuel.
My grandpa was in the Navy.
That's awesome. Grandpa in the Navy. I love it. Beatrice.
My aunt and her wife are both in the Army, and then my great-grandpa was in the Navy for World War II.
Well, that's awesome. Very good. Oh, yes, Duane.
My grandpa was in the Air Force.
In the Air Force? That's really cool. Very good. Well, guys, if you're lucky enough to have someone who is a veteran that is still living in your family, today's the day. I want, send them a text and be like, Happy Veterans Day. Love you so much. Thanks for your service. Tell us if there's something we can do to make your day easier today, because big fan of veteran over here. Big fan of veterans over here. All righty, let's see here. Miss Addie, what is our first essential question today? Oh, I'm so sorry. Addie G. Wait, no. Wait, hold on. Eden! I just called you by your sister's name. Oh my goodness. I just yeah, sorry about that, Eden. Eden, please go ahead and tell us what our first essential question.
How do we use scientific notation
How do we use scientific notation to calculate the incredibly small? Also, did you guys see that? She read it from her math notebook, meaning she wrote it down in her math notebook before I ever asked her to. So thank you so much for that, Eden. That's awesome, but I can only police what I can see. That cuts both ways. Bluey character breeds through the American Kennel Club. Winton. According to the American Kennel Club, his breed is kind but courageous, friendly but dignified, a thick-set, low-slung, well-muscled bruiser, whose sour mug face is the universal symbol of courage and tenacity. Whoever wrote that, I want them to write my obituary. Are you kidding me right now? That is like the best description I've ever heard of anything. Like, I do see part of the correct answer up there, but I need you to be more specific. Anybody want to add something to one of those? Yeah, go ahead, Sina. Well, that's okay. Okay. The correct answer is English Bulldog. English Bulldog. There's English Bulldog, French Bulldogs, and American Bulldogs, and those are the American Kennel Club recognized breeds of Bulldog, and I was looking for that one specific. Watermelon's the fruit. Watermelon's probably tied with peaches with my very favorite fruit. When peaches are good, when watermelons are good, that's what I'm talking about. They have to be good. That's 100% true because, you know, an all right apple is all right. But an all right peach is not all right. An all right watermelon is not all right. Yeah, also bad apples are also bad, which is why I don't eat red delicious apples, which I've always said is a half-truth. They're definitely red. Red delicious apples, totally get it, absolutely red. That's how I feel about it. Granny Smiths are good. Granny Smiths, don't sleep on Granny Smiths. Throw those in a salad. That's good stuff. My favorite, honestly, guys, I really like the Pink Lady or Crips Pink. Do you guys know those ones? They're sour. They're sour and yummy. I like those. Okay. Come on up in 5, 4, 3, 2, 1. Anyway, got a pencil? Scientific notation. And the very small. Okay? Scientific notation and the very small. Okay, let's get those voices off, guys. If you got a song in your heart, just keep it in there for me, please. Let's see here. I got to grab the notes for this. I forgot that there's different notes for this one. There we go. Aha, there we go. Okay, so let's think of the number 123.45678 9. 123.45678 We talked about a number a little bit like this yesterday, and we talked about how that value there is the ones place, which is AKA the 10 to the 0 place. This was the 10 to the first place, and this was the 10 to the what? Everyone, this is the 10 to the second. Now, it turns out that this pattern actually keeps going the other way. So when I say teach, I want you to say, okay, what do you think we call the place values of the tenths, hundredths, thousandths, 10,000ths, 100,000ths, and millionths place? And also, why does that make sense? Give it a shot and teach! Yes, 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 but I needed English Bulldog. That's how, if I was on Jeopardy, it would be like, you'd be like, what is a bulldog? And then I'd be like, more specific. And you'd be like, and I go, and then I'd wait for anybody else. And then I'd be like, English Bulldog, English Bulldog. Next question. Pick again. All right. Can I get you guys back up here in 5, 4, 3, 2, 1. Camilla, what do you suspect these place values are going to be called? They sure would. That's the 10 to the negative 1. Because remember, guys, 10 to the negative 1 is 1 over 10 to the 1. How would you read that fraction out loud? You would say what, everyone? You would say 1/10. That is the tenths place. This is 10 to the negative 2, which would be 1 over 10 squared, which is 1 over 100. Which would, so how would you say that out loud? 1 over 100 is more easily said 1/100th. That's the hundredths place. Then the thousandths place is 10 to the negative 3, 10 to the negative 4, 10 to the negative 5. That looks like a 2, sorry. And then 10 to the negative 6. That's how we can count backwards. Meaning, if I give you a number like this one, got a pencil? 0.000000123. How do you think I could write that as something times 10 to the something, using the fact that when we're talking about these place values, The exponents are now negative because we're talking about the ones, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths places. Give it a shot and teach.
I'm either thinking it's a negative or zero.
It is backwards. Yeah, it's backwards. It's backwards. Same concept, but backwards. So that's the start of it for sure, because I need to have the first digit in the ones place. Very good. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Shh. Elin, do you have an answer for this? So I'm just going to change the order of that. 1.23 times 10 to the negative 6th. How many of us got 1.23 times 10 to the negative 6th? Okay, there's a few ways you can get there. Let's see. Remember, this is times 10 to the 0. This would be times 10 to the what? Negative 1. This one's, and then, and finally, and one more. There we go. See how that matched up with the negative 6? That's one way to do it. The other way to do it is just by counting your decimal. Tell me when the decimal is where I want it to be so that when I write my number in scientific notation, the first digit's in the ones place. Tell me when to stop. So stop here? No, okay, that's okay. Oh, man, wait. I don't know if it's because we got stopped early that happened, but guys, I just want to throw it out there. If I was walking towards speeding traffic, I sure hope you'd give me a better stop than that, right? Like, if I'm walking towards speeding traffic and I'm just like, hey, everybody, how's it hanging? It's good to see you. And I just hear one little voice of Beatrice being like, stop. I'd be like, what was that? Wham! Right? Guys, when you say stop, I want to hear it like I'm about to walk into moving traffic. So tell me when to stop, guys. There it is. Thank you so much. I want to stop right there, and that's 1, 2, 3, 4, 5, 6 spaces, and that's how we can also know it's 1.23 times 10 to the negative 6. I got to tell you, that backfired on me some years ago, because I think kids just weren't getting the concept, so a lot of kids didn't know when to stop. They were like, I don't know when to stop. And this was also when I was doing this in a Math 8 class where we were taking several days on the large values in scientific notation. And so they weren't sure when to stop the decimal. And I was like, come on, yell at me like I'm going to be like run into traffic, okay? And then when I got the decimal to the right place, the only thing I heard was a single student go, keep walking. And I was like, there's this one kid. The funny thing is she was a really nice kid too. I didn't get it. I was like, are you kidding? And she's like, maybe. Okay, let's see here, guys. Let's try another one. Here we go. What is 0.00045 in scientific notation? Give it a try and keep going. Teach! Go ahead and write this down, please. It's part of our expectations. But it's okay. Really common mistake. Happens all the time. Better to happen now than on your self-assessment, and better on your self-assessment than your skill check. That's me.
I was like confused yesterday, and like today, when it's negative,
Uh-huh.
let's say if isn't a negative times a negative
Oh, shall we do one together? Just a moment. I got you. This is good. Hey, if you get it wrong, that's what I want. I want people to make mistakes and we find out what's going on. Okay, let's see here. Can I get you in 5, 4, 3, 2, 1? Jack, what'd you get for this?
I got 4.5 times 10 to the negative 4th power.
4.5 times 10 to the negative 4th power. How many of us got 4.5 times 10 to the negative fourth power? That's perfect. Beautiful. How did you do that, Jack? How did you know it was 4?
Well, first I just started by placing my decimal point where I wanted it.
Okay.
And then I just swooped under the zeros and counted how many times I swooped.
Perfect. Works every time. Works every time. Great. I got one more for you guys. Here we go. Negative 0. Ooh, hold on to your hats. 0, 0, 0, 0, 0, 0, 0, 0, 3, 0, 5. What is that in scientific notation? Teach! Oh, wait a minute. Can I get you in 5, 4, 3, 2, 1? I heard like an embarrassed okay over here. But I hardly heard any of those guys. That doesn't actually meet my expectations. When I say teach and you don't say okay. There it is. But I will say the loudest, proudest okay I heard came from Beatrice. So thank you, Beatrice. So let's, guys, make sure when I say teach, you say okay. Talk to each other. How would you turn this into scientific notation? Again, it's negative 0 point. 1, 2, 3, 4, 5, 6, 7, 8 zeros, 305. Give it a shot, and here we go. I want to be like Beatrice. Teach!
I want to be like Beatrice. Okay!
Beatrice, you did it. You're just like her in every way. Well, then actually talk to each other about how you handle this. Okay. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Shh. No, thank you. Listen. I'm seeing 2 competing answers pop up all over the place. That's your first lunchers. Ella, what was the answer you came up with? Okay. Okay, very good. And then can someone tell me, even if it's not the answer you got, can someone tell me what they suspect the other answer is, even if that's not what they got? Alex, what'd you get? Okay. And then do we have one more? Do we have one more? Annika. So I'm here to tell you guys that these 3 are not equivalent. These 3 all represent 3 extremely different numbers. So when I say teach, I want you to say, okay, given that, because I think some of us might have made the mistake that thinking that 2 of these might have been equivalent, or maybe all of them. I'll tell you right now, they are all 3 very different numbers. And to think about why they're different numbers, imagine if I asked you to get these out of scientific notation, what would your answers be? Use that to answer the question, which one of these is correct? Teach! Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Guys, when I'm pointing at the one that you think is correct, I want you to give it a polite little golf clap. Practice a polite little golf clap for me. That's good. Okay, if I'm pointing at one that you think is incorrect, I want you to give a very quiet, disapproving murmur. Practice that. Oh, you guys are good at this. Okay. How do you guys feel about this one? Okay, that sounds, most people don't like that one. How about that one? Ooh, how about this one? The correct answer is indeed the first one. It is indeed the first one. Can someone tell me why they think these other two felt reasonable to some people? Why do you guys think those might have felt reasonable? Jack?
Maybe because, like, for the bottom one, maybe because the negatives cancel each other out.
Yeah, they're thinking yeah, please, no, yeah, go for it.
Does that have something to do with, like, the exponent being odd so they wouldn't cancel each other
It
out?
actually doesn't matter if the exponent is even or odd. What does matter, guys, is that exponents and coefficients act totally differently, right? This negative means it's the opposite of 3.05. This negative means it's 1 over 10 to the ninth. Since those negatives are totally different, like they're trying to tell us something completely different from the rest of them, this is your correct answer. And we cannot simplify it any further than that. Okay? Beautiful. What if I asked you to go the other way? What is 4.8 times 10 to the negative 13th? How can I get that out of scientific notation? Give that a shot and teach. Ah, someone's noticing a pattern. Tate's noticing a pattern that's going to make this really easy for him. Very good, Juliet. Mm-hmm.
I think it's a little too big.
It is. So you're going to have to use your brain box. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Juliet, what did you get? You know, why don't you tell me? I loved what you said to Camilla. Tell me what you told Camilla. Mm-hmm. Why minus 1? That is correct, but why minus 1? Yeah. Because this decimal will always only have one space to go. So I know it's going to be one fewer zeros in front of the 4/8. And then I'm going to put the decimal right there. Tate actually had, I think, possibly an even simpler way to do that. Tate, what did you think? Okay, I'm sorry. Oh, that's all right. Let me show you what Tate did. At least when I was walking around and I heard Tate speaking, here's what I thought he was doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 4, 8. Point. Done. When I say teach, I want you to say, okay, which method do you feel the most comfortable with? And also talk to each other about why those both work. Teach, teach.
I think I like Tate.
Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Shh. Kenzie, voices off, please. Hey, guys, when I count down, that's actually when the conversations need to stop, not when you're finished, when I count down. Kenzie, which of these do you think makes more sense to you? The way that Juliet did it or the way that Tate did it? Tell me why Tate's works. How come I can just write down all the zeros and then put a point in between the first and the second one? Mm-hmm. That's all right. And we have to make sure we know why it works, though. It's because if we add this first zero, then what we're saying is that it's like this decimal needs to go back 13 places, which is where it goes here. But technically, we need to add a 0 here. Like, if I want it to be reduced, I will accept both of these answers, by the way, with or without the leading 0. I know I prefer the leading 0. So it's like Juliet's way was to put all those zeros minus 1 from your exponent. And if we put the leading 0, minus 1 plus 1 is just the number. So you can do it either way. That can make pretty short work of these, like this one. Got a pencil? Negative 7.01 times 10 to the negative 10th. What would that be, guys? How would you simplify that and teach? Go ahead, talk to each other, guys. How would you do that? Let's get that written, please. That is part of my expectations, and I'm having to say that an awful lot today. I'm hoping that's the last time. That's me. Yeah, well, so like, for example, if we all lose like this, which I don't suspect will happen, but if we did, we'd all have to stay for a minute after class, but the stars of the week would be exempt from that. For today. Alrighty. Can I get you back up here in 5? Have a seat for me, Dean. 4, 3, 2, 1. Much better countdown from 5. Thank you so much, everybody. I think you do deserve a point for that. Very good. Okay. How would you write this into standard form and out of scientific notation? Abby, why? What would you do? 2, 3, 4, 5, 6, 7, 10. Oh, got it. So just plopped it down here. Or did you actually think like 1, 2, 3, 4, 5, 6? Did you do that or did you do that? Okay, very good. Love that. Love it. How many of us got 0.0000000000701? There is a slight mistake, though. Did anybody catch it? Or oh, you did? I'm sorry, Abby. I didn't hear that. Tell me. Oh, really? 1, 2. Did I mess that up? 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I should be good on place value. That's what it is. It was a negative 0.00000000701. Very good. Excellent. Okay. Yes, Sina. So sorry, can't hear Sina. I see what you mean, because that's what we did with our big numbers, right? So that's the thing, Sina. If I'm going to write this out of scientific notation and get it into standard form, you have to be really careful. Is my exponent positive or negative, Sina? So does that mean that my orange decimal is going to move to the left or to the right? It's going to move to the left. And notice it only has one number to skip when I move it to the left. Yeah, when we're talking about big numbers, you're absolutely right. That would be like if that was times 10 to the positive 10th, that would be negative 701 with 8 zeros after it. But that's the thing about negative exponents. That's why that cool thing that Juliet showed us, where you can just take that number and just do 0.90701, or Tate showed us, you just draw down 10 zeros, put a decimal between the first two, and then draw 701 on the end. That's why that works, is because there's only one number in front of that, because in order to be in scientific notation, the first digit has to be in the ones place. Yeah, was there a question I heard over here? Millie? Yeah, if you do it Tate's way, yes. If you do it Tate's way, like if you just draw 10 zeros and put it down, that's exactly what I want to see you doing, okay? Perfect. I think we're ready to do this, guys. So when I say teach, let's go ahead and work on our self-assessment. But first, let's open up to that page. Will you guys open your planners to page 54? Page 54. Page 54. Go ahead and write this down, guys. Page 54. Guys, don't open your Chromebooks yet. We're writing this down in our planner. If you don't have your planner, write it down in your notes. Leo, I want you to write this down in your notes, please. Page 54 for Tuesday, November 11. Tuesday, November 11. Today we're going to be working on 9.2, which is scientific notation, plus the really small. Now, before you snap your planner shut, hopefully on page 55, for Friday, November 14th, I really hope you already have, let's see here, 7.5 expires. 7.5 will expire this Wednesday. That was our ordering and identifying real number, or this Friday, excuse me. If you flip the page to page 57, page 57, I don't know if I already had you write this down, for Friday, November 21st, that's going to be 8.5 expires. That is our power rules. So it'll be dead on 8.5. And then one last thing before you snap it shut, guys. Where is it? There it is. For on page 54, oh, sorry, 56. Page 56 on Wednesday, November 19th, we have our scientific notation skill check. Scientific notation skill check. Whew! Lot to do, but we got it all. When I say teach, I want you to say okay. Go ahead and start working on 9.2. Last time, guys, a student, I always tell 5th period your record 4 out of 4 first try. And the record last time was 4 out of 4 first try 4 minutes. Somebody got 4 out of 4 first try 2 minutes. Next. Oh, there you go. Okay, so let's see what you guys can do with it. Set the record nice and good. So see what so it's hard for 5th period to figure out. Let's get to it and teach. All right.